Welcome back to the VTC course on Wireshark. In the previous videos, we had started with the Aussie model and the 7 layers or building blocks of today's computer networking. To further enhance our know-how of networking, we will start to look at some of the most important protocols, starting with the IP and the TCP protocols. The IP is a connectionless protocol which manages addressing data from one point to another. IP fragments large amounts of data into smaller transmittable packets. The major components of Internet Protocol datagrams are IP identification or IP ID. IP ID tries to uniquely identify an IP datagram. The term protocol describes the higher level protocol contained within the datagram. Time to live, or TTL. TTL attempts to keep datagrams and packets from routing in circles on a network. When TTL reaches 0, the datagram is dropped from circulation. The TTL also allows traceroute to function, which identifies each router in a network. TTL completes this action by sending out datagrams which successively increase the TTL duration, and then tracking when those TTLs are exceeded. The source IP address, which is the IP address of the host where the datagram was created. The destination IP address, which is the destination of where the datagram should be sent. TCP packets are connection-orientated and are used to transmit data. The connection-orientated nature of TCP packets makes it a poor choice for source IP address spoofing. Many applications use TCP, including the web, email, FTP, and the Windows Remote Desktop Protocol. Communication is established on a network with the TCP handshake. The TCP handshaking is very important for network communication. Before any data can be exchanged between the two hosts, they must first agree to communicate with each other. For instance, host A sends a packet with the SYN flag set to host B. If host B is willing and able to communicate, it returns the SYN packet and also adds an ACK or acknowledgement flag to the return packet. Host A begins sending data and indicates to host B that it has also received the ACK. When the communication between the two hosts ends, a packet with a FIN or finish flag is sent, and a similar acknowledgement process is followed once again, concluding the data transfer. Another important component of TCP is sequence identification, which is where each packet that is sent is part of a sequence and provided a sequence number. Through these sequence numbers, TCP handles complex tasks such as retransmission, acknowledgement, and order of the data. In the next video, we will continue with network protocols and begin with UDP and the ICMP protocol.